This is second video of the topic series thermal physics. In this topic, we are going to discuss about thermal convection and radiation. Initially, we will come up to learn about thermal convection. How does thermal convection occurs? We know that if you heat up a substance, it tends to expand. When a substance tends to expand, it tends to lose its density. The reason is that with the temperature, the distance between molecule increases. As a result, the density becomes lower. Therefore, if you heat up over here, the density of the particles become very lower. Then these less denser particles, what happen? They tends to go up. We know that the less density substances tends to float. With that, in this case, you can understand that less density substance goes up. With the meantime, this area become vacuum. Let's see how does this affect for this convection. When the what do you call that hot substance goes up, you can see that this area become what do you call loss of molecules or particles, means we call it's a lack of particles. Then to fill up this lack of particles, the cool particles with high density cool particles, they try to come down. So this perform a process called thermal uh, convectional current. So what you can understand is these hot substances can become less dense and they go up. As a result, the cool substances with a higher density, they try to come down. So this perform a convectional current and it circulates as shown over here. To perform this system, we know that the particles must be free to move. That you have to be understand clearly. If the particles are rigid, you cannot observe any kind of the convectional currents. Right. This is a simple experiment to perform a convectional current. What you can do is you can put a small potassium permanganate or some kind of a color dot into a hot flask and we tends to heat from bottom. So in that case, you can see these hot particles. When these hot particles, they go up, they bring up these colored particles as well. So you can clearly see this convectional current. This is some kind of what you call animation to show this convectional current. These hot particles go up. To fill up this vacuum area, the cool particles come down. So it performs a convectional current as shown over here. This is another experiment to show that convectional current very easily in our classroom. What you can get here is that we can get a small box and we cover and we can put a small transparent sheet over here. Then after that, we fix some kind of holes over here and we light up a small candle at this place. And if you keep some kind of a burning incense stick, you can see usually the smoke should go up. But in this situation, when you light up the candle over here, we can see the smoke goes down and it tends to go from this side. How does this happen? So you know that when you heat up this candle, the hot air become much less dense. As a result, they goes up. So this area become vacuum. To fill up this vacuum, the air try to come down. When the air try to come down, it bring the insane stick smoke as well and it goes over here. When these smoke and the air particles get heated up and they go up, as a result, you can see the smoke is coming out from this corner. So that is a simple experiment to show the convectional current using smoke. Right. Then there's another problem. Why thermal convection only occurs in fluids? We know that, as I mentioned in the previous, to perform the convectional current, um, the air particle must be free to move. So you know that only in fluids we can see the air particles are free to move, but not in solid. Solid particles are not free to move. Therefore, you cannot observe any kind of thermal convection in solids. The next topic today we need to learn here is thermal radiation. We know that how does this thermal radiation occurs? Objects at any temperature emits radiation. We know that at a low temperature even we can see this thermal radiation, but if the object is cool, the thermal radiation is very less. The number of thermal radiation emitted is very less, and those radiation are really weak. Means we can see the radiation emits with low frequency. But when you increase the temperature of this object, the number of radiation become more, and it emits energy, what we call radiation, with very powerful ones, means with very high frequency. So you can see when the temperature, these are the cool areas, it's just like this. And when you become hot, but we can see, you can see more number of area, more number of thermal radiation somewhere like this. Though that is a simple idea of thermal radiation. We know that for conduction, you need vibrating atoms. As a result, in most of the situations, to perform the thermal conduction, you need a solid material, or very rarely you can see thermal conduction occurs in fluids as well. But when you consider about the thermal convection, in this video we have discussed, it perform in mostly fluids. But in radiation, radiation is electromagnetic radiation, and it does not need any medium to travel. That is why the radiation can travel from one place to next place without having any medium, just like some kind of vacuum, right? So you know that best example is, we know that the sunshine, the hot sunshine reaches the earth without having any medium. So you know that it travels from sun to a planet through vacuum. There is no space, there is no medium in the space. But you know that sunshine or whatever the what you call hot rays traveling from any star to a nearby planets. So we can understand that the thermal radiation does not need any medium, right? So if you just brief up, you can understand that conduction mainly occurs in solids, convection mainly occurs in fluids, and radiation, anywhere you can observe any kind of radiation or medium is required for thermal radiation, right? So this is one day-to-day example for convectional current. So when you heat up over here, the what you call that hot particles go up and it perform convectional current, and they handle to your hand, it emits a thermal energy through conduction. And if you hold your hand close by to a fire, you can see the thermal radiation. There is no contact from here to here. So mainly you can see, you can observe the thermal radiation reach from the fire to your hand. Those are the some kind of examples about moving the thermal energy from one place to another place. These are the main ways, the conduction, convection, and radiation.